Welcome to module 15 of programming in C++. In this module, we will discuss about const-ness. So, to understand the const-ness of C++ objects will be the main objective for this module, and we will also see how const-ness can be used in class design. The outline is as given, it will follow on the left hand side. We will talk about constant objects, member functions, data members, take an elaborate example and also discuss mutable data members. So, first let us introduce constant objects. We have seen const-ness earlier when we talked about the procedural extension of C++, the better C++ part. We had seen that if we make an object constant or a data constant, a variable constant, then that cannot be changed. That has be set a value at the initialization time, and after that, that value cannot be changed. So, this we had seen for built-in type data, int, double and so on, the pointer. Now, the same thing can be done with C++ objects. So, we note that like objects in built-in type, the user defined type objects can also be made constant. Now, naturally if an object is made constant, then none of its data members can be changed. So, these are main. So, an object has one or more data members, once you make it constant, none of them can be changed. The primary consequence of making an object constant is the type of its this pointer. We remember that this pointer refers to the address where this object resides. This pointer now becomes a constant, now becomes a pointer to a constant object. So, earlier when we introduced this pointer, we saw this is the type of the this pointer, it is a constant pointer to the object of the class, but now it becomes a constant pointer to a constant object of the class. So, introduction of this const in the type of this pointer is a consequence of declaring an object as constant. Naturally, a constant object cannot invoke the normal methods of the class. This is understandable because we are saying that a constant object should not be allowed to change the data members of the object. Now, instead of directly changing, if a method is invoked, then that method can in turn change the data member. Therefore, to avoid that, constant objects are not allowed to invoke the data member, invoke the member functions. We will see how this in spite of this, how constant objects can actually function. So, let us first take an example to understand this. So, here is an example of a non-constant object. So, this non-constant object has two members, one that is private. So, this non-constant object has a private member and a public member. So, we have introduced two member functions, get member and set member, to read and write the private member, and the public member naturally can be directly read or written. So, here is an application which is trying to read the private member, write the private member, read the public member, and overall print the object. So, all of these will work fine, you already understand this very well. So, now we take a constant object. So, the same example, the difference that we are making is now we have made the object constant. So, before the declaration of the object we have written const. So, by this the object myConst obj is become a constant object. Rest of the class is the same, it is just the use of the object which we have made constant. Now, with that you will notice that all these four use of the object gives compilation error. So, in the first case it is trying to invoke a get member to read the private member and print it. Now, this gives an error, as you can see here. It says that cannot convert this pointer from my const my class to my class ampersand. We will understand little bit more of what it really means, but to take the bottom line, the compiler is saying that since the object is constant, you cannot use it to invoke a member function. The same error is obtained in this in case of set member, in case of print. Error 1, 2 and 4, all of them give the same error. And if we try to directly write to the public member, as we are trying to do here, there is a public member. So, if we try to directly write to this public member, then we get a different error, which says that you cannot assign to a data member when the object is constant. So, this ensures that if the object has been declared as constant, then we cannot access or change the data member functions of that particular class through that constant object. Now, naturally, on one side this achieves the objective, because it has been able to protect the data members. Being constant, it has to protect the data members that they cannot be changed. But now, on the other side, it basically defeats the purpose, because for example, if I just wanted to read, like in here, I just wanted to read the private member, I am not being able to even do that, or I just wanted to print the object, I cannot even do that, because I cannot invoke any member function. So, we need another support in C++ to be able to do this. That is, for constant member functions, for constant objects, we need to introduce constant member functions. We will see how this will be done. So, constant member functions are a new feature to support const-ness in C++. It is just like another member function. The only difference being that in the constant member function, after the function prototype, the header, this is the header part and this is the body part of the function. In between these two, you write the keyword const, and when you write this keyword const, the member function is called a constant member function. Now, what it does, as we all know that when an object wants to invoke the member function of the class, then the address of that object get passed as a this pointer in that member function, and we know the type of the this pointer. Now, when you declare the constant member function, then the this pointer that is passed gets changed in its signature. It now is a pointer to a constant object, because you are saying that the member function is a constant member function. So, what compiler wants to emphasize is only constant objects can invoke this member function. So, we have already seen that the constant objects have this pointers which are of this type, which are constant pointers to constant objects, and constant member functions need a this pointer of the same type. So, now it is possible that a constant object would be able to invoke this constant member function. The consequence of that is what is given here is, if a member function is constant, then no data member can be changed in that function. So, if we have the set member function and if we declare that to be a constant member function, so that a constant object can invoke it, then we will get a compilation error, because in this function we are trying to change a data member by making an assignment to it. So, to sum up, a constant member function can be used by constant objects only to read data members, only to access data members, but they cannot be used to write or change the data members, and in any case non-constant member functions cannot be invoked by the constant object. So, with the combination of these two, we achieve the objective that a constant object can only maintain the data members that it already has, maintains the same values, but it cannot allow to change the values of the data members. Now, the next point here is also interesting, that a non-constant object can invoke a constant member function. This is simple, because a constant member function guarantees that it will not make change to an object. If the object itself is non-constant, then we do not care whether it is changed or it is not changed. So, you are saying that it is a non-constant object and a constant member function invoked on it says that I will not make any changes, there is no contradiction. So, to sum up, a non-constant object can invoke constant member function as well as non-constant member function, but a constant object can invoke only constant member function. So, all member functions that do not need to change an object, those must be declared as constant member function to make sure that any constant object can also use them, can also invoke those member functions. Let us look at an example again. So, we go back to the same example. Now, what we are doing, we look at the member functions and decide whether they should be constant or they should not be constant. Get member is only reading a value, so we make it constant. Print is only reading and printing values of data member, so we make it constant. But this one, the set member, we cannot make a constant member function, because set member intends to change the data member. So, if we have two objects now, one non-constant and one constant, then as you can see that the non-constant object can make all the changes as we have seen before. Constant object now can invoke the get member function, because it is a constant member function, and read the value of the my prime member data. It can print, because print is a constant member function, but it cannot do any of these, and that is why I have made them, I have commented them. It neither can invoke set member to change the value of the private member, because set member is a non-constant member function, cannot be invoked by the constant object, and of course, it cannot directly make assignments to the public member, because it is a constant object. So, with this we achieve the objective that we can control exactly which member functions can be invoked by the constant object and protect all the values of the data members as they have been set at the time of construction. Now, let us introduce a third type of const-ness that C++ support. We have just talked about constant objects, where if I make an object constant, then the whole of that object is constant. I just cannot make any change to that object, none of the data members can be changed. But often what we will need is, we will need to change some data members, while some other data members should remain constant. And I have mentioned several examples. For example, here making an employee record, and for that employee record you have an employee ID, you have a date of birth. Certainly, once a record has been created, we do not expect the employee's ID to be changed, and of course, date of birth cannot change. But the same record, same object will have designation, address, salary, all these should be changeable, because that is what the programming is all about. So, several other examples, if I am dealing with a student, then again roll number, date of birth should be non-changeable, rest should be changeable. If I are talking about the credit card example we discussed earlier, then the card number and the holder of the card should be non-changeable, whereas the cards do have a certain period of issue. So, once those are over, we would like to reissue the card again. So, the date of issue, the date of expiry, the CVV, all these will change. Even the holder can apply and change for an address. So, these should be changeable. So, constant data members are a feature to support this kind of selective constness as a part of the object. So, we do this by making the data members constant by using a const keyword in front of its declaration. So, a constant data member cannot be changed even when the object is not a constant. Of course, if an object is constant, then nothing can be changed, but even if an object is non-constant, then the constant data member will not be able to change its value. Therefore, it must be set at the time of initialization of the object. So, let us look at this. So, now we have an example where we have two private members. This is a non-constant one and this is a constant one. We have made it constant by putting this const keyword. Similarly, I have shown two public data members, one of them is constant, the other one is non-constant. We have a constructor which initialize all of them, and we have the set, get on all of these members. Naturally, what will happen is, if I am saying that this data member is constant, I do not expect it to change. So, when we try to write a set function on this data member, which will assign a value to C prime m, then the compiler gives you an error, because if this could compile without any error, then an object would be able to invoke this and make changes to the data member. Be careful to understand that in this case, the member function does not need to be a const member function. This is a non-const member function, but the reason you will get an error is because the member itself, the data member itself that you want to change itself has been declared to be constant. So, the set function cannot be invoked. Similarly, if you look into this line where we are trying to assign a value to the public data member which has been declared as constant, we will get another error from the compiler, because if you look into the declaration of the public data member has been declared as constant. So, it should not be changeable. So, this is how, by using const-ness in front of the data members, you can selectively make the data members constant, whereas we are able to make changes. We will be able to, for example, here we are making assignment to this particular data member, which is the public member, and that assignment does not give you an error. We are changing this, which is also allowed, because this is not a constant member. So, now let us take a relook in our credit card example and see how constant data member can be used for a better design of the credit card class. You have already seen all these class designs, all these codes. So, I will not reiterate them, just note the small changes that have been made. For example, if you look into the string class, then we have introduced in here, we have introduced the copy constructor and copy assignment operator, as was discussed in module 14. And importantly, in the print function, we have introduced a const, because as we said, the print function is not expected to change any data member, and we have just learnt that any member function that does not change the data members must be declared as a constant member function to protect that no constant object inadvertently can change this. So, we will make all these print functions as const. The date class, again in the date class we have provided the provisions for copy, and we have made all these functions, print, validate date, day, all these functions as const member functions, as is the protocol that we have agreed to. The name class, again copies are added and the print function has been made into a constant member function. We have seen this class also earlier. It can be used to define the name of any person. The address class, copies added, and again the print function has been made a constant member function. Now, finally, we are with the credit cards class, which make use of this string, date, name, address, all these classes, and we have the same set of data members and functionality. Now, what we do? We introduce a number of set methods. Earlier, we had just been constructing the credit card object and printing it. Now, we have introduced a number of set methods by which the different members, data members of the credit card object can be changed. That is, I can set the name of a new holder, I can set the address, I can set the issue date and so on, and of course, print has been made constant. So, this is the change that we have made, and with this let us see what consequences happen. So, if you look into the credit card application now, in the application we have used the set members to make changes. So, all of these changes show up in terms of it was originally created, the object was created for Sherlock Holmes having certain address and some certain dates, and now it has been edited to have a different holder name, different address and so on. So, we could change all of these different fields, which are fine, but the disturbing part is we are able to change the name of the holder, which according to a credit card issue system should not be possible. A card issued to someone cannot be reissued to someone else. So, we have to stop this possibility of changing the name of the holder. So, this is where we will now use constant data members to. So, what we do? Now, we have learned how to do this. If we do not want the name of the holder to be changed, so before the declaration of the name of the holder, we put a const. So, the name of the holder now becomes a constant data member. So, in a credit card object, this cannot be edited, which means that the set holder function that we had written, the set holder function now becomes a error, because it is trying to assign to the holder which is defined as constant. So, you get this kind of a compiler error saying that you cannot have this kind of a function. So, if I cannot have this kind of a function, then naturally I cannot change the name of the holder. So, we achieve our objective in that. So, this is just the same class cleaned up. We have now removed the set holder function, because that function cannot be compiled, and therefore, there is no way to change the set holder, and we will use this to again go through the application once more. Now, in the application, now we have this is commented out, this cannot be done, but rest of the changes can still be done. I can still change the address, the issue date and all those. So, we are safe, but it is still possible that I can actually change the card number itself. I can edit the card number or replace the card number, put a different card number. So, how do we guard against that? How do we take care that this cannot be changed? So, for this we will have to see that the card number is a pointer variable. So, it is supposed to get allocated and it will point to a string. So, there are two ways that the card number can get affected. One is I can traverse this pointer and change the string, I can edit the object itself. The other is I could reallocate a new object and put in the place of the card number, that is I can just reallocate this. So, this is the situation like this is a card number, there is an allocation here of the card number some 4, 3, 8, 6 and so on. So, I can either edit this or I can change, add a new card number, and so both of these have to be stopped. This should not be possible, this should also not be possible. And we discussed this situation while we discussed about constness of pointers, that here what we need is we need the pointer as well as the pointed object to be both to be constant. So, this is what we simply do, we make it a constant pointer and we make it point to a constant string, constant object, and with this it should not be possible, it would not be possible to change it. But now we face a different kind of a problem. The problem is, look at how this was initialized in the body of the constructor. You know, at this point the object has been constructed, initialization is over, and in this we have not initialized the card member, because there is quite some code to write to initialize that. We have to allocate the string, which we do here. Before that we have to get the length of the string, then we allocate the string and then we copy the given number string into this. So, we decided to do this in the body of the constructor, but now that this has become a constant pointer, this assignment is not possible, because card member has already been initialized in the initialization list. Further, since the object itself is constant, this copy is not possible, because the object also is constant, it is pointing to a constant object. So, if I do strcpy, if I copy the string, then I am actually changing that string object. So, both of these will give error. So, we will have to make sure, we will have to take care that we actually do all of this task in the initialization list itself. We will not be able to do this in the body of the constructor. So, now if you look carefully, we have introduced the initialization of the card member in here. Please try to understand this, do not get scared by the little complexity of this expression. If you go one by one, C number is basically the given card string. So, first we do find the length of it, then we make an allocation for it. So, we get a pointer having adequate space where the card number can be put, and then we do strcpy to copy C number into this location. So, it is like first we get the length, say the length is 16, we add 1. So, we get 17, this 1 is for the null character. Then we make an allocation. So, we have an allocation of an array of 16 into some location, and then we copy whatever my input string is into this using the strcpy. So, that my card member gets initialized to this string, and it will have to be done here, it will have to be done in the initialization list, because both the pointer card number pointer as well as the string that it will point to have become constant now. But with this we are able to protect and construct the object in a way, so that you cannot make any changes to the card number once the credit card object has got created. So, we have just seen how to create constant objects, constant member functions and constant data members, and how to use that in the design.